So we were in the case one, where we started with the m is less than n. Of course, there may be two possibilities: either m is less than n or m is greater than n. Of course, equal to n is also possible, but m equal to n has already been discussed in our last lectures, where the number of equations were equal to the number of variables, right? So m is the number of equations and n is the number of variables. Or equivalently, you can say that m is the number of rows in A, n is the number of columns in A, right? Okay, fine. So this was our case number where we started with the m less than n, right? And we did these two questions, and there was an observation that whenever m is less than n, that is, number of equations are lesser than the number of variables, and the right hand side is not equal to 0, then the system cannot have a unique solution. And the reason for this is that uh, a rank of that matrix A can be less than or equal to m, of course, because there are total m equations. So a matrix having m rows cannot have rank more than m, right? And since m is lesser than n, it implies that rank of A can never be equal to number of variables, and which was essentially required to have a unique solution. It means that you cannot hope for a unique solution whenever you have a lesser number of equations as compared to the number of variables, right? Likewise, we have these two questions here, and in this question we have had two equations and three variables. So please do not hope for unique solution. Similarly, for this question we had two equations but three variables, so do not hope for unique solution, right? Okay, so now we'll move further, and why don't we take b equal to 0, because in these two questions we took b not equal to 0. So what happens if I take b equal to 0? So this is my next question to you, and I'm writing it here. What happens if the right hand side becomes 0, and that's the 0 vector, right? This is a question, and to search the answer of this question, we should formulate a question. Actually, it's always good to answer something by writing a good question, right? So the question addressing to this is question number 3, and which is solve, and this time the system will be homogeneous to 3x plus 2y plus z equal to 0, and the second equation is x plus y plus z equal to 0. You can see that the right hand side terms are 0, right? Because we are trying to search the answer for b equal to 0, and of course we are in the case number 1 when number of equations are less than the number of variables. We have only two equations and three variables, right? So let us form the augmented matrix, and I'm not writing now augmented matrix because everybody knows that the augmented matrix is C and A partition B, but B is 0 this time, so I will write 0, right? And this will give you C equal to, we'll pick the first, these coefficients of x, y, z, and those are 3, 2, 1, then partition 0, then 1, 1, 1, partition 0. And then we search the diagonal. You can see that this is diagonal, right? This is the principal diagonal, and you have to focus on the elements below the principal diagonal. Of course, this is the element you want to target, and you want to make it 0. And the simplest row operation is that R2 implies thrice of R2 minus R1. So this is a elementary row operation, though this operation is invalid when you are going to find the determinant of a matrix, but this operation becomes valid in the cases when you are dealing with a system of equations, because the presence of this equality sign, this invalid operation becomes valid, right? And of course everybody loves to use this operation as compared to this one, because nobody wants to use this operation because this is involving fractions actually, right? So in order to avoid fractions in the matrix, you just should opt for this operation, which is valid here only, this operation is not valid in evaluating the determinant of a matrix, right? So please be careful about this remark, or it's a caution for you, all of you. So while using this operation, I will get 3, 2, 1, 0, and this will be 0, and 3 minus 2 is 1, 3 minus 1 is 2, and this is 0. So you observe that this is now the row reduced echelon form of C. And here rank of A, if you observe the rank of this matrix, the rank is clearly 2, right? And if you see the rank of full matrix, this is also 2. So you can say that rank of A equal to rank of C equal to 2, and we generally call this number as small r, right? But unfortunately this is less than 3. And what is 3? 3 is actually n. N is the number of variables. Here the number of variables are x, y, and z, right? So we have 3 variables, but the rank is 3. So of course we are inside the case m less than n. That's what we are studying, right? Okay. So this indicates that because their rank is equal, due to the equality in their rank, you have a solution. But due to the this inequality, since r is less than n, you have infinitely many solutions, right? Thus, infinitely many solutions exist, right? And if I ask you to find those infinite solutions in just one line, so that can also be done by assuming n minus r variables, and n minus r will be 3 minus 2, and 3 minus 2 is equal to 1. It means that you have to assume one variable as arbitrary if you really want to answer this question, right? So let me form two equations from this system. If you see this matrix, augmented matrix, then you'll have two equations. First equation will be obtained from this, and second from this, right? So I will write them. This gives, by this I mean the last matrix. The last matrix gives two equations. One is 3x plus 2y plus z equal to 0, and second equation is y plus 2z equal to 0. Since you are going to assume one variable as arbitrary, and let that one variable be z, which is assumed as arbitrary. So I'm writing here z equal to k. Okay, fine. And then I will plug this z equal to k in these two equations. That will give me, this implies y is equal to minus of 2k, and if I put here, then I will get 3x is minus 4k plus k, that will be 3k. So x equal to k, I think, yeah, x equal to k. So these are the values of x, y, and z. Thus x equal to k, y equal to minus 2k, and z equal to k is solution. And this is just not just one solution. This is a class of infinite solutions, because you can always give infinite values to k, because k is arbitrary, right? This is solution, right? So you saw that if the right hand side is 0, then you have infinite solution, and of course you can't have unique solution. Let me ask Muhammad Tabish, who joined recently. Muhammad Tabish, can we have no solution? Can we have no solution when the right hand side is 0? There always exists. Actually, I missed the yesterday class. No, you were present in yesterday class, but you were logged in yesterday's class, but you were not answering. Maybe you went somewhere. Maybe you went to market or to, no sir. Vikat Raj is saying no sir. Mohammad Abish, I went to do some work, but you are logged in throughout the class. What kind of work? You have opened some business. You are doing BTech here, na? What kind of work? You have your class here and you are doing some business, side by side business. Is it so? Market. And you were logged in class. What is the point of getting logged into the class and you are wandering in the market? This is a crime. I mean, you can't be present at two places, no? You are present in class and you were wandering in important. The class was not important. Class was not important. Is there anything more important than class for a BTech student? Hmm? Sorry, and this is that's the great word invented by Europeans. Sorry, right? You say sorry, I mean it means that everything is okay now. But that is not okay actually, because you missed yesterday class. This was your first crime, and the second crime was that you didn't watch the recording of that yesterday class. You did two simultaneous crimes, and it implies that you should be hanged twice to death. I mean, फांसी दो बार. वो आपने गुनाह कर दिया. और मजे की बात यह रही कि कल हम आपको पुकारते रहे मोहम्मद ताबिश मोहम्मद ताबिश मोहम्मद ताबिश, क्योंकि आपका नाम यहाँ पे आ रहा था बराबर. और बाद में मालूम चल रहा है कि वो मोहम्मद ताबिश नहीं थे, उन्होंने अपनी जगह एक पुतला खड़ा कर रखा था मोहम्मद ताबिश के नाम का. मोहम्मद ताबिश तो मार्केट में घूम रहे थे. बताइए कितने अफसोस की बात है. तो ये धोखा है या नहीं है, ये बताइए मोहम्मद ताबिश. क्या ये धोखा था? कल आपने धोखा दिया हमें. अब आपके पास कोई जवाब ही नहीं है. अगर आप क्लास में नहीं हैं, आप कहीं और हैं, तो आप लॉगिन मत करिए. सर आई विल कवर इट अप. नहीं, यू कैन कवर द सिलेबस ना, बट यू कांट कवर दैट व्हाट हैपेंड टू मी यस्टरडे. आई फेल्ट लाइक चीटेड. आई कुडंट स्लीप होल नाइट. पूरी रात भर में इस वजह से सो नहीं पाया कि मुझे धोखा दिया गया है. मोहम्मद ताबिश ने धोखा दिया है कल. इसका क्या होगा? रियली सॉरी सर. चलिए मान लेते हैं कि आप रियली सॉरी फील कर रहे हैं. ठीक है. There always exist infinite many solutions. Won't happen again. Let us see that though it's a great saying that history repeats itself. इतिहास जो है खुद को दोहराता है. काश वो बात गलत हो जाए और आप सही हो जाए कि ये रिपीट नहीं होगा. ठीक है. खैर हो सकता है कि रिपीट होने के लिए मैं ही ना हूँ, ऐसा भी हो सकता है, क्योंकि वक्त में क्या राज छुपा है कोई नहीं जानता. ऐसा हो सकता है कि दोबारा कभी आपको मुझे सॉरी कहने का मौका ही ना मिले आज के बाद, ये हो सकता है इस हफ्ते के बाद, ये भी पॉसिबल है. खैर, there always exist infinite many solutions when b is equal to 0. If b equal to 0 and if m is less than n. So this is a good remark. कुछ और इसके अलावा नहीं हो सकता. हमेशा ही ये होगा, हमेशा ही infinitely many solution होंगे जब जब b 0 होगा और साथ में n छोटा होगा n से. राइट. अब वक्त आ गया है आगे बढ़ने का, और आगे बढ़ने से पहले मैं आपको बता दूं कि हम करने क्या जा रहे थे. हम करने ये जा रहे थे कि हम दो केस पढ़ रहे थे. पहला केस तो वो जब m छोटा था n से, और अब दूसरा केस हम वो पढ़ेंगे जब m बड़ा होगा n से. राइट. तो मुझे उम्मीद है कि आप लोग तैयार होंगे केस नंबर 2 में जाने के लिए. तो यहाँ मैं लिखने जा रहा हूँ केस नंबर 2. सभी के सब बहुत ध्यान से देखें, क्योंकि अब थोड़ा चीजें बदलने वाली हैं. पिछली बार था m छोटा n से, इस बार m बड़ा हो जाएगा n से, यानी कि नंबर ऑफ इक्वेशंस विल बी मोर देन द नंबर ऑफ वेरिएबल्स. राइट. तो अब मेरे सवाल ही बदल जाएंगे. जहां मेरे सवाल ऐसा हुआ करते थे कि इक्वेशंस कम हो सके, m इज द नंबर ऑफ रोज. यस विकटराज यू आर राइट, m इज द नंबर ऑफ रोज. जहां मेरे दो इक्वेशंस और तीन वेरिएबल होते थे, अब चीजें बदल जाएंगी. अब शायद तीन इक्वेशंस और दो वेरिएबल, ऐसा कुछ चीजें होने वाली हैं. राइट. सो लेट वी स्टार्ट द क्वेश्चन नंबर. इसको नया सवाल का नंबर दे देते हैं. क्वेश्चन नंबर 1 ही दे देते हैं इसको. क्वेश्चन नंबर 1 इस केस का तो पहला ही सवाल है. राइट. तो एक काम करते हैं, इक्वेशंस ज्यादा वेरिएबल्स कम. तो चलिए पहला है 2x plus y equal to 5, and second is 3x minus y equal to 5, and 7x plus 2y equal to 16. So you can see that we have three equations and we have only two variables. Equations are more, variables are less, right? Okay, so forming the augmented matrix, you know that there is the augmented matrix, that is C equal to A partition B, and of course this time it is non-zero, so I'll write A partition B, right? That will give me C equal to, the coefficients are 2, 1 partition 5, 3 minus 1 partition 5, and 7 2 partition 16, right? And of course you need to find the diagonal. This is diagonal. You can see that I'm just highlighting the diagonal. This is the diagonal, right? And these are the target elements. This should be made to 0. This is your second target, this is your third target, and that will be addressed later, right? So first I will try to make 0 this target number 1 and target number 2 by applying the row operation. Like R2 implies twice of R2 minus thrice of R1, and R3 implies twice of R3 minus 7 times of R1. So these are the operations which should be used to have the form which is close to a echelon form. So 2, 1 partition 5, and 6 minus 6 is 0, and this will be minus 2 minus 3, that will be minus 5, and this will be 10 minus 15, that will be again minus 5. This will be 0, and 2 4 minus 7, that will be minus 3, and 32 minus 35, that will be again minus 3. So this is your form which is close to echelon form, but it's not actually echelon form, because still you can see that there are elements below this principal diagonal which are non-zero. You can see that you have one more target left, and this is your target. This should be target number 3, and the operation you need to apply is R3 implies 5R3 minus 3R2. So using this operation, you will have 2 1 partition 5, 0 minus 5 partition minus 5, 0 0 partition 0. Now it's echelon form of the original matrix, because all the elements below the principal diagonal have been reduced to 0. So we can write that it is RREF of the original matrix C. Right. Fine. Now it's just an observation that you need to observe the rank of A and rank of C. Now who will tell me that is it so that their ranks are equal? Of course their ranks are equal. Rank of A is 2 and rank of C is 2. Both are equal, right? And this number rank is denoted by small r, and this time fortunately that is equal to 2, which is equal to n, a number of variables. You please just count the number of variables. Only 2 variables were the yes, unique solution. Aryan Parikh, you are absolutely correct, because only 2 variables were there, and rank A equal to ranks equal to number of variables. And if this happens, then system is consistent. Consistent means the system is correct. I mean, it has some answer, and unique solution exists. The system has a unique solution. That's good. And in order to find that unique solution, you just need to pick up the 2 equations from here and then solve them, right? The last matrix gives minus 5y equal to minus 5, and that immediately gives you y equal to 1, right? And the second one, 2x plus y equal to 5, and if you put y equal to 1 here, then you will get x equal to 2, right? So this is the answer. This is a unique solution, right? Therefore x equal to 2 and y equal to 1 is unique solution. Of course it is a single solution, right? Okay, now we take another question question number 2 of this case. And I will change the coefficients so that you may have a case of infinitely many solutions. So let me change few digits. 2x plus y equal to 5, and this first equation has been kept as same. Second, I will just obtain as 6x plus 3y equal to 15. You can see that this is just a multiple of first equation by the factor of 3, and I will try to create third equation, minus 2x minus y equal to minus 5, right? Okay, solution. So if you try to form the augmented matrix, I'm just writing the elements of augmented matrix. That will be 2, 1, partition 5, 6, 3, partition 15, and minus 2, minus 1, partition minus 5. So this is your augmented matrix, and again you can identify the diagonal, and this is the diagonal, right? So if you apply the operation, the operation should be R2 implies R2 minus 3 times of R1, and R3 implies R3 plus R1. So these are the two operations which will help you to get equivalent form in just one step, I think. Yeah, 0, 0, 0, and this also will be reduced to 0, 0, 0. So we are lucky this time that in just one step we got the equivalent form. So this is R, R, E, F, infinite solution. Gaurav Kumar is exactly right. R, R, E, F of C, right? And you just observe that, as Gaurav observed also, that rank of A is equal to rank of C, and of course the rank is how much is the rank? Both matrices have rank how much? Yes, the rank is 1. Okay, and this number is written as small r, and that is Muhammad Tabish also confirmed the answer that it is 1. Okay, Vikat Raj also saying 1. Less than what? This is less than 2, and 2 is the number of variables. So what do you hope for? You hope for the system is consistent. Good thing is that the system has an answer. But how many solutions? Infinitely many solutions, right? And if I ask you to find the infinite number of solutions, so you have to assume. Now Muhammad Tabish will answer. Assume how many variables will be assumed as arbitrary. Muhammad Tabish. No, Muhammad Tabish. Yes, Muhammad Tabish, you are correct. N minus r will be equal to 2 minus 1 equal to 1 variable as arbitrary, right? So the equation that is achieved from the last matrix, that is 2x plus 5, you can see that this gives 2x plus y equal to 5, and you assume one variable, that z is assumed as k, say, then this will give you what? Sorry, not z is not there. I have to assume y. Z is not in the variable, so y equal to k. That gives you x equal to 5 minus k upon 2, right? Therefore this is the answer, x equal to 5 minus k upon 2 and y equal to k is solution. And it is not just a single solution, it is a class of infinite solution, because k is arbitrary. You can choose any k and you can have as many solutions as you want, right? So this is case number 2. In two problems, we saw that in question number 1, this was a unique solution, and in question number 2, we saw that this was an infinite solution. So there comes a question in our mind, that is it possible then that we can have no solution? So let me give you a small example for that. That case is also possible. I mean, you can have any of the three cases. unique solution, infinite solution, and no solution is also possible. I have to design a question in that fashion only. So the question is this: solve 2x plus y equal to 5. You can see that this equation is same as this one. I'm just changing the coefficients. If b not equal to 0, Aryan Parikh, yeah, of course, b not equal to 0, then no solution can happen. And if b equal to 0, then there is no point of no solution, as we discussed earlier. Whenever the right hand side is 0, there is always a solution. The good thing about the right hand side being 0 is that there is always a solution. You always have some answer. And the reason of this will be told in next lecture actually. Why the right hand side, when right hand side is 0, why there is always a solution? The answer lies in the geometry of equations actually, and I will explain that in the next lecture. So this is the first equation, and let me construct the second equation by just writing 4x plus 2y equal to 6, right? And let me take the third equation as minus 2x minus y equal to 7, right? So I hope that this will give the no solution, right? Solution. Augmented matrix will be 2, 1, partition 5, 4, 2, partition 6, and minus 2, minus 1, partition 7. So this is your augmented matrix, and now you are very comfortable with all the row operations, and you are comfortable in identifying the elements below the principal diagonal. So I'm just applying the operation, and that is R2 minus twice of R1, and second operation should be R3 implies R3 plus R1. Okay, fine. So that gives you C 2, 1, partition 5, 0. This is also 0, but this is not 0 because 6 minus 10 is minus 4. And this is 0, 0, and this is what? 12. Yeah. And you can see that this is just an echelon form of C. So it has been reduced to echelon form, but the observation is that you're observing that rank of A, if you see the rank of this matrix only, rank of A, rank is equal to 1, right? And if you see rank of C, the full matrix, this one, its rank is 3. Sorry, again, no solution. No, Shivam, actually, I missed one step. This is not correct, actually. I have to I have to remove this. Actually, the last form is not an echelon form. This is absolutely wrong. This is not echelon form, sorry. Because you see that when you remember the definition of echelon form, when you go down the diagonal, when you go like this, when you just move along the first column, then the number of leading zeros should increase. You can see that this second row has 2 leading zero, and this third row also has 2 leading zero, though there is a scope to make this element as 0. So this is not an echelon form. So I too made a mistake, and of course students may be confused at this point because this is not an echelon form. Please pay attention, right? So I have to apply one more operation, right? So the operation is this, R3 implies R3 minus sorry, plus 3 R2. So this is the correct operation to have the actual echelon form. So this is, sometimes it is very confusing because already you have made all the elements below the principal diagonal 0, but there is already a scope, always a scope to make this element 0. So whenever there is a scope to have more 0 elements below the diagonal or on the diagonal also, then please make them 0, right? Okay, 0, 0, minus 4, and on using this operation I get 0, 0, 0. Now I can say that this is, yes, this is the echelon form of C. Now it's correct, though it will not affect the answer, but since wrong step is a wrong step in mathematics, right? So this is row reducing form of C, and you observe that rank of A equal to 1 and rank of C equal to 2. So that is rank of A is less than rank of C, and when it happens, it implies that no solution. Therefore, no solution, because the system is inconsistent and has no solution. I hope you got this point. And we can't write a remark here, like we made a remark here for the case m less than n. You just observe this observation, that whenever m was less than n and b was not equal to 0, the system cannot have unique solution. Such kind of remark cannot be written here, because we just saw that in these three questions we have no solution, infinite solution, and unique solution. So everything can happen, anything can happen. So there's no remark actually, right? But what is b? Yeah, b, of course b is not equal to 0. Yeah, I think you are asking about what happens when b equal to 0. Is it your question, Vikat? This is your question. What happens?
No, sir.
Okay,
So my question is, what is B?
B is the right hand side. This is B. 3, 5, 6, 7. 5, 6, 7. The column matrix 5. This is B. The right hand side is
Okay,
called
sir.
B. Because the
Okay, sir.
system
Okay.
is actually Ax equal to B, no? Right? A is this matrix. This is A. And B is this matrix. Right? So
Yes, sir.
yeah. So what if B equal to 0? अगर b 0 ले लिया जाए तो तब क्या होगा? क्या तब भी ऐसे ही होगा? क्या तब भी तीन बातें हों, तीनों केस बनेंगे या नहीं बनेंगे, वो देखना पड़ेगा, राइट? So what if b equal to 0 for this case m greater than n, right? So I will form a question for that, and that will be question number 4, right? Solve 2x plus y equal to 0, and this is 3x plus 2y equal to 0, and 5x plus 6y equal to 0. Vikat, can you answer a small question, that since we are having b equal to 0, is it possible that you have no solution? Is it possible that you have no solution whenever right hand side is 0? Vikat?
Yes, sir.
Is it possible that you have no solution when right hand side is 0? Is it
No,
possible?
sir. It is not possible.
Not possible, because whenever right hand side is 0, it is always a solution, right?
Yes, sir.
Okay. Now augmented matrix C will be 2, 1 partition 0, 3, 2 partition 0, and 5, 6 partition 0. And again, you can identify the diagonal. You can see that this is diagonal. And below this diagonal, we have 3 elements which are to be reduced to 0 by using row operation. Okay. So let me use the row operations to make them 0. So first will be R2 implies 2R2 minus 3R1, and second will be R3 implies 2R3 minus 5R1. I hope you got this, how I use these operations to make them 0. 2, 1, 0, this will be 0. 4 minus 3, 1, this will be 0. 10 minus 10 is 0, and 12 minus 5 is 7, and this will be 0. Now, still one more element left which can be reduced to 0. So the operation will be R3 implies R3 minus 7 times of R2. So you will get C equal to 2, 1 partition 0, 0, 1 partition 0, and 0, 0. Very good. Krish identified that we are going towards the infinite solution, but is he correct? I think he is not correct. Yeah, Gaurav Kumar corrected him that this is a case of unique solution, because please focus on n. N is the number of variables. The number of variables are 2, not 3, right? So observe that this is of course the row reduced echelon form of C, and you just observe that rank of A is equal to rank of C is equal to 2, and that is of course equal to R, and that is of course equal to 2, which is equal to N, and is the number of variables. So we can surely say that thus unique solution exists. And if you want to write that unique solution, then what will be that? You will just pick up this equation and this equation, and you will get that solution. So from the second one, from this equation, you will get what? You will get y equal to 0, and from first equation you will get 2x plus y equal to 0, and when you plug y equal to 0 here, then you will get x equal to 0. And it is already confirmed from the theory that whenever you have a unique solution in case of homogeneous system, you need not to spend your time to find those solutions. Those solutions are always the trivial solution, that is x equal to y equal to 0. This is called the trivial solution, right? And we have mentioned this in theory. If I want to show you, I just mentioned it yesterday, I think yesterday or a class before yesterday, that the trivial solution is always 0 0 0. Somewhere I wrote here this
Sir, a class
somewhere.
before yesterday.
Yeah, class before yesterday. Yeah, yeah, this one.
Sir, sir, when you told us the alternate method, sir.
Huh?
Yes, sir. Yes.
Alternate method?
Both, sir.
Actually,
Both, sir. In both yours, sir.
what are you trying to say? You want me to solve this by alternate method?
No, sir. No, sir. I said in both the method,
Okay.
you tell us the triangular solution will be 0 0.
Yes, 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 yes. Of course, of course, of course, of course. So this is the trivial solution, and yeah, this is the first example when b equal to 0. Let me change my example. Again, I am saying that whenever you have b equal to 0, there can be no case of no solution. There will be always a solution or infinite solution, right? So I'm moving to my next question, question number 5. Solve 2x plus y equal to 0. This is the first equation. And 4x plus 2y equal to 0, right? And 6x plus 3y equal to 0. So these are the three equations, and you can always solve these three equations using this augmented matrix solution. C equal to, this is 2 1 partition 0, 4 2 partition 0, 6 3 partition 0. Yes, of course, infinite solution will be there, and you can identify the diagonal. This is a diagonal. And you have three targets. This is number 1, number 2, and number 3. Three targets to be reduced to 0. So just to use the raw operations, right? So that gives you C equal to 2 1 partition 0, 0 0 partition 0, 0 0 partition 0. So every element has been reduced to 0, and this happens many times. So this is just the RREF of C. You can see that this is a nice echelon form where you have no leading 0 in row 1, and you have 3 leading 0 in row 2. You have 3 leading 0 in row 3. Of course, the number of leading zeros in row 2 and row 3 are same, and there is no increase in the number of leading zeros as you are moving down along column 1. I told you earlier that in echelon form, when you go along, when you move down along the first column, the number of leading zeros should increase. So my question to Gaurav Kumar is that since we are moving down along this first column, but the number of leading zeros are not increasing, they are same in row number 2 and row number 3. So how can we accept this as an echelon form? Gaurav Kumar, will you answer this question?
यस सर, यस सर. सर
Okay, please.
सर पहला सेकेंड रो में सर
Yeah.
सेकेंड रो में सर 0 है, 3 0 है सर.
हाँ
और
बिल्कुल
थर्ड
सही.
रो में एक और 0 आने का पॉसिबिलिटी नहीं है सर, तो इसलिए सर
Very
echelon
good.
फॉर्म कहेंगे सर.
ओके, और मतलब कि कहने का मतलब है कि जब 3x3 की मैट्रिक्स है तो आखिरी रो में 4 एलिमेंट कहाँ से लिखते हैं, यही कहना चाह रहे हैं आप?
यस
जैसे
सर.
कि क्लासरूम में सीटिंग है आपकी 25 बच्चों की, 5x5 का मैट्रिक्स है. आप जानते हैं ना मैट्रिक्स क्लासरूम में जो सीटिंग होती है वो मैट्रिक्स के अरेंजमेंट ही होता है, वो भी क्यों रोज भी होती है क्लास में और कॉलम्स भी होते हैं. तो मैं एक ऐसे
यस सर.
क्लासरूम की बात कर रहा हूँ जहाँ नंबर ऑफ रोज हैं 5 और नंबर ऑफ कॉलम्स हैं 5 और एक सीट में एक ही बच्चे को बैठाना है. ऑफ कोर्स ये जो कोरोना की सिचुएशन चल रही है इसमें तो एक सीट में दो तो बैठ नहीं सकते हैं, राइट? तो 5x5 की आप मैट्रिक्स सीटिंग है इनसाइड अ क्लासरूम जिसमें 25 बच्चे बैठ सकते हैं. तो लास्ट रो में तो आप 6 तो बैठाएंगे नहीं, जाहिर सी बात है, क्यों?
यस सर. यस सर.
तो वही चीज यहाँ पे हो रही है, 0 को आप कहाँ पे बैठाएंगे, राइट? चाहे कोरोना ना भी होता तो भी आप मैट्रिक्स के अंदर थर्ड रो में जिसमें कि 3 एलिमेंट आ सकते हैं आप 4 नहीं बैठा सकते, ठीक है? क्लासरूम में तो फिर भी हम एडजस्टमेंट कर लेते हैं. खैर, तो रो रिड्यूस इक्विवेलेंट फॉर्म आ चुकी है, इन्होंने बिल्कुल सही जवाब दिया गौरव ने. और हम आगे बढ़ जाते हैं. बस अब तो कंक्लूजन आपको लिखना है, तो कंक्लूजन लिख देते हैं. सिंस रैंक ए कितनी आ रही है? 1. और रैंक सी भी 1 ही आ रही है एंड दिस नंबर इज कॉल्ड स्मॉल आर. बट अफसोस की बात यह है कि 2 से थोड़ी छोटी आ रही है. और 2 पे क्यों तवज्जो दे रहे हैं हम 2 पे? 2 क्योंकि नंबर ऑफ वेरिएबल्स हैं, इसलिए हम 2 की बात कर रहे हैं, ठीक है? तो ये किसकी तरफ इशारा कर रहा है? ये केस जिंदल. वेयर इज जिंदल?
Yes sir, yes sir, yes sir, yes sir.
अच्छा, जिंदल तुम हो वहां पे, ठीक है. तो जिंदल बता दो कि भाई ये किस तरफ इशारा कर रहे हैं? ये रैंक ए बराबर रैंक सी लेकिन छोटा है नंबर ऑफ वेरिएबल्स.
Sir, yes sir, infinite solution है sir.
वेरी गुड, इनफाइनाइट सॉल्यूशन. मोहम्मद ताबिश ने भी हामी भर दी है कह के कि इनफाइनाइट सॉल्यूशन है. इनफाइनाइट सॉल्यूशन एग्जिस्ट. और अगर इनफाइनाइट सॉल्यूशन निकालने की बात करी जाए तो कैसे निकालते हैं इनफाइनाइट सॉल्यूशन? ये हम किससे पूछें? विकट राज हैं यहाँ पे?
यस सर.
वेरी गुड. विकट राज, इसका सॉल्यूशन निकालने का वक्त आ गया है और आज वक्त आ गया है कि तुम अपने आप को साबित कर दो सबके सामने इसका सॉल्यूशन निकाल कर.
सर सबसे पहले n-r.
वेरी गुड. एज्यूम n-r कितना आएगा? 2 - 1
1. Yes sir. 1.
वेरिएबल
Sir, y is equals to k.
वेरी गुड. y को k मान लेते हैं.
Yes sir.
इक्वेशन भी तो इक्वेशंस भी बता दो फिर. एक ही इक्वेशन मिलेगी शायद यहाँ से.
So 2x plus y equal to 0.
2x plus y equal to 0. तो x कितना आ जाएगा?
y by k minus y by k.
y by k आराम से. हाँ, माइनस
Yes,
y by
sir.
2.
Minus y
माइनस
by
y by
k.
2.
Y
y की
by
वैल्यू
2.
तो
Yes
k है
sir.
ना, माइनस
Yes
k by
sir.
क्यों? बस अब
Yes
तो
sir.
सॉल्यूशन लिख देते हैं. x इक्वल टू माइनस k by 2, y इक्वल टू k इज सॉल्यूशन, राइट? और k के बारे में जिक्र करना ना भूलना कि k कौन है, कहाँ से आया है, किस दुनिया का है, ये भी बताना जरूरी होता है ना. बच्चे क्या करते हैं, इतना सा आंसर लिख के छोड़ देते हैं और ये बताते नहीं है k कहाँ से आ गया. k क्या लगता है किसी का? तो k क्या लगता है? कौन है k?
Arbitrary.
क्या नतीजा निकला इससे? इससे तो ये नतीजा निकला कि जब हमने b को 0 लिया तो k कैन बी नेगेटिव. यस मोहम्मद ताबिश, k कैन बी नेगेटिव. k नेगेटिव भी हो सकता है, पॉजिटिव भी हो सकता है, 0 भी हो सकता है, कुछ भी हो सकता है k, क्योंकि k तो आर्बिट्री है. k वो हो सकता है जो आप सोच सकते हैं, ठीक है? कोई प्रॉब्लम है तो प्लीज पूछ लीजिए. एनी रियल नंबर. यस, आर्यन परीक ने कहा एनी. और मजे की बात आपको एक चीज बताऊं मैं आपको, ये मतलब ये आपके लिए टिप दे रहा हूं मैं आपको जाते जाते, क्योंकि ये टॉपिक खत्म हो रहा है इसलिए टिप देना है. और वो टिप ये है कि जो ये वैल्यूज है ना, ये x और y की, अगर आप इन्हें किसी में भी पुट कर दें किसी इक्वेशन में तो सेटिस्फाई हो जाएगा इक्वेशन, राइट। x इक्वल टू -k/2 कॉमा y इक्वल टू k satisfy 2x प्लस y इक्वल टू 0। और ऐसे भी कह सकते हैं कि वो उसको भी सेटिस्फाई करेगा और इसको भी करेगा, बट एक्चुअली इफ यू ऑब्जर्व दैट दिस इज नथिंग बट इफ यू मल्टीप्लाई दिस बाय 2 यू विल गेट दिस। Yes or no? If you multiply the first equation by 2, you will get the second equation. And if you multiply the first equation by 3, you will get the third equation. Actually, this was the trick which I was using to make these questions. ये मैं अपने दिमाग में यही सब कर रहा था सवाल बनाते हुए, क्योंकि मैं जानता था कि मुझे तीन नहीं, मुझे एक ही इक्वेशन चाहिए एक्चुअली में। असल में तीनों इक्वेशन वो एक ही हैं, वो लग रही हैं तीन लेकिन वो है एक, क्योंकि जो दूसरी और तीसरी है वो पहले से ही बनाई गई हैं, इसीलिए ऐसा हुआ कि इसके इनफाइनाइट सॉल्यूशन आए। अगर मैं तीनों इक्वेशन अलग अलग बना दूं तो फिर यूनिक सॉल्यूशन आएगा। अगर मैं तीनों एक जैसी बना दूं तो फिर जाहिर सी बात है एक ही इक्वेशन को तीन बार लिखने का क्या मतलब है, लेकिन मैंने फिर भी लिखा, राइट। और यही मैं आपको बताना चाहता हूं कि मैंने क्यों लिखा। इसीलिए लिखा क्योंकि मैं चाहता था कि इनफाइनाइट सॉल्यूशन आ जाए। और लिखा कैसे, इसी तरीके से पहली लिखी मल्टीप्लाइड दैट बाय 2 गॉट द सेकंड इक्वेशन एंड मल्टीप्लाइड द फर्स्ट बाय 3 टू गेट द थर्ड इक्वेशन। और इसीलिए शायद ये बात सच है कि जो आंसर आएगा ये पक्का सेटिस्फाई करेगा पहली वाली को, और अगर पहली वाली को करेगा तो दूसरी को भी करेगा और दूसरी तीसरी को भी करेगा, ऑफ कोर्स, राइट। कोई कंफ्यूजन है तो प्लीज पूछ लीजिए, क्योंकि समय आ गया अब अलविदा कहने का।
No, sir.
राइट।